I'm going to talk about fractional and in general non-positive integer exponents. So as an example, x to the 1/2 or x to the 2/3, x to the pi, x to the 0. How do you make sense of an expression like that? This is actually a question that my dad had for me when I was a kid, probably 30 years ago. And his question was, what on earth does it mean to multiply something by itself a half times? So we're all familiar with the basic rules of exponentials. So if we have x to the 3, we know that this means x times x times x. And x to the 1 just means x. X to the n means x times x times x, where this happens n times. So you could describe the exponential as a basic shortcut and that says how many times are we multiplying x by itself. That was how my dad thought of exponentials. So he couldn't conceive of x to the 1/2, and no matter what I did, he wasn't willing to accept what that meant. So x to the 1/2 or x to the 3/4 or x to the pi, like what on earth do those mean? And it's like my dad was completely insistent that you can't multiply something by itself pi times. That's not a bad objection. And so how can we rationalize this and give it a meaning that makes sense? And if Dad was still around, I think I could now explain it to him. But the key is that there's a little bit of a bait and switch required. And his definition of exponential has to be swapped out. So you can no longer, if you want to give meaning to these guys, then you can no longer use the rule that an exponential means the number of times a value is multiplied by itself. Basic idea is that if we have, let's say we have x to the 3 times x to the 4. Well, what does that mean? If x to the 3 means x times itself 3 times, so x times x times x, and x to the 4 means x times itself 4 times, then we have x times x times x times x, which is x times itself 7 times. So there's nothing surprising there. You could generalize this. You could say, all right, well, suppose you had x to the a times x to the b, where a and b are positive integers. So a and b are numbers like 1, 2, 3. So non-zero positive integers. So clearly you can write x times x times x a times, multiplied by x times x b times, and you can count those up, and what are you left with? You're left with x to the a times x to the b is x to the a plus b. So this is a property of the definition that x to the n equals x times itself n times. So we can now say x to the a times x to the b equals x to the a plus b. Now, the key to understanding fractional exponents is that we have to swap our definition. We can no longer say x to the n is x times itself n times. What we have to do is have to say, okay, we've identified this property of exponentials as we know them. we now have to change the meaning of exponentials. We have to say that this is now the meaning that's the meaning of an exponential. So now, whenever we say exponential, we don't mean x times itself n times. We actually mean this relationship. And that is the key to explaining to Dad fractional exponents, because you have to be willing to change your definition so that you no longer think of an exponential as defined as x times itself n times, but you have to say this relationship is the meaning of exponential. That is the key, because once you do that, once you've, like, I'm calling this a little bit of a bait and switch, because you're the student who's gone into the used car dealer with $3,000 in your pocket, prepared to buy a crappy old beater of a car, and somehow by the end of your interaction with that used car dealer, you ended up with financing at 15% and a car with a sale price of $10,000, and you don't really realize what happened, and somehow this happened. So that let me explain why this works. So if this is the rule for the meaning of exponential, now we can say, all right, well, this obviously works for integers, and you can justify other expressions. So like now we say, all right, what is the meaning of x to the 0? Well, x to the 0 times x to the n equals x to the 0 plus n, which is x to the n. So if this is true, this means that x to the 0 has to equal 1. And so based off of the new meaning of exponential, that exponential is something that satisfies the property of x to the a times x to the b equals x to the a plus b, then you can now give a meaning to x to the 0. Similarly, you can say, all right, well, what does x to the minus 3 mean? Well, if x to the minus 3 satisfies the rule, then we have x to the minus 3 times x to the 3. This has to equal x to the minus 3 plus 3, which is x to the 0, and we just discovered that is 1. So x to the minus 3 is the inverse of x to the 3. So we've determined that, and you can extend this to any integer, and you basically determine that for integer n, so if n is any integer, x to the minus n equals 1 over x to the n. And again, the key to this is the rule. So we have to be willing to give exponential this meaning, and say that exponential doesn't mean x to the itself n times. So if we're willing to do that, now we can give meaning to fractional exponents, or really any exponents. So we can say x to the 1/2. Well, what does that mean? And this was the one that my dad had trouble with. And so if x to the 1/2 has a meaning, and it obeys the rule, then it must be true that x to the 1/2 times x to the 1/2 equals x to the 1/2 plus 1/2, which is x to the 1, and that is x. So x to the 1/2 is some number times itself that equals x. Well, that's the square root of x. So we've determined that x to the 1/2 equals the square root of x. You can do the same thing for any other fraction. So let's say x to the 1/3. Well, x to the 1/3 times x to the 1/3 times x to the 1/3 must equal x to the 1/3 plus 1/3 plus 1/3, which is x to the 1. So we've determined that x to the 1/3 is that number that when multiplied by itself 3 times equals x. So that means that x to the 1/3 has to equal the cube root of x. So I think that somewhere along the line, I just accepted x to the 1/3 as a definition of x to the cube root of x to the 1/3, and x to the 1/2 as a definition was the square root of x. And I saw that this was justified because it satisfied the same definition of the same property of exponentials. But for that to really make sense, you have to be willing to change the definition of exponential so that the definition of exponential is the property x to the a times x to the b equals x to the a plus b. You have to be willing to make that the definition of exponential, and that's the bait and switch. You can justify any kind of exponents you want. So for example, x to the 2/3. Well, if you take x to the 2/3 times itself 3 times, then by this rule, our new definition of exponential, this is x to the 3 2/3, which is x squared. So x to the 2/3 is the cube root of x squared. And you could do the same thing for any rational fraction. So you could say that x to the n over m, where n, m are integers, equals the mth root of x to the n. Giving that meaning relies on switching the definition of exponential so that it then obeys exponential. It's anything that obeys this rule. And as the last example, you can give meaning to the exponential to an arbitrary number. So for example, let's say, x to the pi. What does that mean? Well, let's say we approximate pi is approximately equal to 3.14. So now that is 314 over 100, or 157 over 50. So we can say that x to the pi is approximately equal to the 50th root of x to the 157. And you could extend that to whatever precision you wanted to and come up with approximate meaning for any exponential, regardless of whether the value is rational or not. That's the rough idea, and it all depends on switching the definition of exponential. So we have to say x to the n plus m equals x to the n times x to the m. We have to be willing to make this the definition of exponential. And we have done a bait and switch where we started off with x to the n equals x times x times x times x n times. You have to be willing to throw out this as the definition of exponential. My dad wasn't willing to do that. And you have to switch your definition of exponential to the property that integer exponentials satisfy. And once you do that, you can define exponentials for any argument. Well, Dad, I wish I could explain this to you now. I think you might be willing to accept the meaning to the x to the 1/2. Thank you for listening.